So in the discussion on the previous page, the first thing that should be done is to state the hypotheses. We'll define mu as the mean of the differences, the regular minus the kiln dried, in the corn yield for a plot of land. Okay, since we want to test the hypothesis that kiln dried seeds yield more corn than regular seed, then regular minus kiln dried should be negative because we think that it's regular, which is a smaller number because it's yielding less than the kiln dried. So we're taking a bigger number away from a smaller number, kind of like we did with the problem that we talked about on the quiz 2 pages ago about the college students and texting. We should get a negative number because I'm thinking I'm taking a larger number and subtracting from a smaller number. But the null hypothesis is at the same. It doesn't matter which type you use, regular or kiln dried, that the difference should be 0. They should be the same. So a lot like the texting example, but the alternative hypothesis is that I'm going to get a negative number when I do this difference because I think kiln dried should yield more. Like I said, I'm taking something bigger away from something smaller. Note that if the difference was defined in the reverse, where it was kiln dried minus regular, then I'd be taking something smaller away from something bigger. So I'd be saying greater than. Then the alternative hypothesis would not be mu is less than 0, it would be greater than 0. Either definition of the difference is fine, but the alternative hypothesis has to be consistent with whatever definition you choose. So just once you stick to one or the other, either regular minus kiln dried, that's negative, or kiln dried minus regular is positive, make sure you stick with that all the way through your whole discussion, and then it should be fine. And so either one's right, as long as you don't mix them up in your discussion. Okay, secondly, after we state our hypotheses, we'll check conditions. First, the variable is difference in yield, which we defined as the regular minus the kiln dried. Initially, we said that. Okay, so we analyze the dot plot of differences. 2, the sample size is quite small, n equals 11, so it's difficult to determine the shape of the distribution. However, we can see that the data, the differences, are not heavily skewed and there's no extreme outliers. Therefore, we assume that the distribution of differences in yield for all seeds will be normal, and we proceed with the t-test. Thirdly, even though the problem does not state it specifically, we assume that Gossett knew what he was doing when he chose the seeds at random. Hopefully it was truly random. The use of matched pair design controls for idiosyncratic differences in the plots. For example, one plot being more fertile or getting more sun or whatever, etc. We're hoping that the way he chose these, it made it so there's no confounding variables. Hopefully. Now, let's see. The results from StatCrunch, okay. Once I put these numbers in there, the paired t hypothesis, the difference in the mu's, mu1 minus mu2, the mean of the differences between regular and kiln dried seeds, I put these alternative hypotheses in there that mu of the differences is 0. For the null hypothesis, the alternative is that mu of the difference is less than 0. We got that the mean is negative 33.72, et cetera, et cetera. The standard deviation is 19.95 or so. The t-statistic is negative 1.69, and the p-value is 0.0609. So the test statistic being negative 1.69 and the p-value being 0.061, basically, if you round it. The p-value is small, but it's not small enough if we use a significance level alpha equals 5%, because 5% in decimal form, 0.05. This is not smaller than this. So I don't have enough data to reject the null hypothesis, or don't have a strong enough conclusion. So the data from this experiment does not provide strong enough evidence to conclude that the kiln dried seeds yield more than the regular seeds, unfortunately.